All right, this is going on page 49. And we are going to start with this little warm-up, and we're actually going to divide using long division like we learned in elementary school, okay? And there's a reason we're starting this way. So, and we'll work through this together. It's all fine and good. But these are skills that you need to have anyway. It's just going to lead us into what we're doing. So I'm going to divide 59 into this number. So 59 goes on the outside, right? And we're dividing that into 101,952. Okay? Not a square root. So when we divide, right, I want to figure out how many, I don't worry about the entire big number, but I start with how many times does 59 divide into 101? Once. So I put the 1, and where you put it is important. It goes over the ones place there. So then 1 times 59 is 59, and then I subtract, right? So 101 minus 59 is what? 42. Good. It's 42 because and then I bring down the 9, right? So I got 429. Now, instead of guessing and checking here, you use a little bit of estimation. 60 would go into 429 how many times? How many times does 6 go into 42? How many times does 6 go into 42? 7. Okay, now, and I'm not even kidding about this. I think I'm going to start giving y'all multiplication facts quizzes. Like you flip it over and you got 1 minute. Because if you do not know your multiplication facts, yeah, exactly. And guess what? It's still hurting you because you don't know what 6 times 7 is, right? Come on. Oh, I'm sorry. I went all the way back to 6 times 7. All right, so this is 7. Pardon me. And then when you multiply, there's no more estimating. We have to actually multiply. So 7 times 9 is what? Woo, 63. Okay. So 3, I carry my 6. 7 times 5 is 35. Plus 6 is 41. Okay. And this is 16. And I bring down my 5. Right? So 60, you can think of 60 instead of 59. 60 goes into 165 how many times? Twice, because 3 would be 180, right? Because 3 times 6 is 18. So this is going to go in there twice. So then 2 times 9 is 18. 2 times 5 is 10, plus 1 is 11. Okay, so look, when we subtract this, the hundreds subtract out, right? To do this, I can do 65 minus 20, and then I would add how much back? 2 back. So 65 minus 20 is 45. Add 2 back, and I get 47. And then I bring down the 2. Okay, well, if you're lost, then you've got to be able to subtract those numbers and borrow and carry, because, again, this is pre-calculus, guys. If you can't add and subtract, multiply and divide, I don't know. If that's what's holding you back, it's really kind of sad. You need to practice. Okay? So then I'm at 472. So 60 goes into 472 only 7 times because the 8 would get you to 480, right? But maybe this divides evenly, maybe it does not. And so it does. And instead of 8, what do I go with? I'm sorry, instead of 7, I go with 8. I'm sorry, I said that wrong. I go with 8. And then 8 times 9 is what? 72. So there's a 2. I carry my 7. 8 times 5 is 40, and that's 47. And then when I've run out of room, but then I get that 0. So my answer then is 1728. Honestly, y'all are laughing. I'm not trying to make you feel stupid, but I'm going to tell you right now, there ain't nothing about this. Because you have, like, no hope of being successful for the rest of the year and in calculus if you cannot do basic arithmetic. So you need to practice. Practice your multiplication facts. Make flashcards yourself. And again, if you have little brothers and sisters or cousins, tell them you're helping them with them. They don't need to know you're learning them too, but you've got to know them. that is honestly what the biggest struggle for a lot of what you're doing is. You don't realize it, but I promise you, things become much easier when you're more comfortable with those things, okay? And you've got to, that's on you. You've got to practice that. All right, so now let's divide this one, and we're doing another one for a specific reason here, because the same process applies to the rest of this. 13 is going to divide into 5,467, okay? So how many times will 13 go into 54? 4. So this is 4, and then when you multiply something by 4, all you have to do is double it and then double it again. So 2 times 13 is what? 26. And then 26 times 2 is 52. And you know, and I'll say a lot, think in terms of money, and sometimes people don't know what I'm talking about. If you have 26 cents, picture in front of you a quarter and a penny. If you double that, you now have 2 quarters and 2 pennies, and that's where your 52 comes from. Does that make sense? If you can break it down and think about money and picture change in front of you, then that's how things are working together anyway. So you get 52. So then I subtract, and I get 26. So 13 goes into 26 how many times? Twice. So then 2 times 13 is 26. And I subtract, and I get 0. Okay, and bring down my 7. Oops, bring down my 7. So, well, 13 goes into 7. It doesn't, right? So is my answer 42 and a remainder of 7? No, because that's why it's important that you line this stuff up. I have something missing here. How many times does 13 go into this? 0 times. And then 0 times 13 is 0. Now my remainder is 7. Does that make sense to you? So placement when you're doing this, because along the way, maybe nobody made you put them in the right places and you got sloppy with it, it lets you know when you're missing something. So that's going to be important when we do this with polynomials as well. It's literally the exact same process as what you do here. We're just doing it with variables. So my answer then is 420, okay? And I would just put a remainder of 7. I would get a fraction and it would be 7 over what? 13. 7 over 13. Okay, everybody okay with that? That exact same process gets applied to your polynomials down here, which again is a review from Algebra 2. And it might have completely blown your mind the first time you did it because it looks terrible. Like when you look back, if you just glance back at your notes when you're done, there's just stuff everywhere and it looks difficult, it looks ridiculous, but it is not hard. You just have to actually write your stuff out and line your stuff up correctly. So let's look at number 3. Okay, so it says divide using long division. So on the inside of the house is this, because this is getting divided by this, so I make my little divisor thing here, and I get x cubed plus 4x squared minus 16x plus 8. And on the outside, I get x minus 2. So when you go to start this, we all remember that we actually did this, right? You remember doing this at some point? Okay? I mean, you may not, I don't expect you to pass a quiz right now on it, but it's part of Algebra 2. You did it. All right? So just stick with me. It's really not all that bad. Okay? Way easier than you think it is. You take this first term here and this first term here. So if I take x to the third power and divide by x, what am I left with? X squared. Everybody agree with that? So I write that above my x squared term. It's very important that you actually line things up. So just like we did up here. So like up here, once I decided my answer was 4, right? I divided and I put a 4 up here. Then I took this 4 and I multiplied it by this and put it down here, right? So that's what I'm going to do here too. I'm going to take this x squared, I multiply it by x, and I get x cubed. Then I take x squared, multiply it by a negative 2, and I get minus 2x squared. Now, you're going to subtract these. You were actually shown originally when you do this here, I'm going to write something, but then you can, but I'm going to erase it. So you're shown to do this, okay, which is correct. There's nothing wrong with it. But then you have to distribute. So I would say instead of doing this and actually not distributing, which is what's going to happen, instead the exact same thing is just to go through and change the sign on each one, because that would be like distributing that negative. You with me on that? So you just write it all down, Go through, change the signs, and then combine them. So then what happens here? They cancel out. That's good. So then here I have 4x squared and 2x squared. What do I get? 6x squared. And then I bring down the minus 16x. Everybody good with that? So then I do this again. I take x, and I'm dividing it in here. So 6x squared divided by x leaves me with what? 6x, right? So that's what I'm going to put here, and it's a positive 6x. So then I take that 6x, multiply it by x, I get 6x squared. Then 6x times a negative 2 gives me negative 12x. After I write it down, I go through and change the sign on each term. Then I combine them. So this first term zeroes out again, and what do I get here? Negative 4x, and then I bring down my 8, and I get plus 8. So then I take this negative 4x and divide it by x. What do I get? Negative 4. Be very careful with your signs. So then negative 4 times x is negative 4x. Negative 4 times negative 2 is a positive 8. I go through and change the sign on each one. Both of these things zero out, so my remainder is 0. So when I divide these, my answer then is x squared plus 6x minus 4. Yes, we're going to do one. We're going to do a couple different examples where a couple different things happen. We're not going to do every single one of these, but some different situations pop up, so I want to make sure you see all of those. Okay. Are we good? Any questions at all? Yes, exactly. So basically, this right here then, this equals x minus 2 times this. And yes, if I multiplied it back in, this is what I should get. And that's one way you could check yourself if you wanted to. It's a very good question. Okay with that? Anything else? You know what's funny is that once we start using variables, you're like, I hate the variables. I want the numbers back. And then I divide it with numbers, and you're like, oh my God, that's terrible. And you probably like the variables better here, right? Yeah. Eventually, we make you believers that with the variables, it's actually usually easier because there's less mathy stuff you can even do, right? I mean, it's better. All right, so let's look at number 5. So I'm going to take 2x plus 7, and I'm going to divide it into 2x cubed plus 5x squared minus 19x minus 42. So I take this first term. I don't worry about the 7 or any of the rest of the terms over there. I just look at this and this to begin with. So 2x cubed, when I divide that by 2x, what am I left with? X squared. So I put x squared above my x squared term. So then x squared times 2x gives me 2x cubed. X squared times 7 is a positive 7x squared. Then don't forget the step where you go through and you change the sign on each one. These zero out. This is negative 2x squared. I bring this down and I get minus 19x. Everybody with me? So now I take 2x, I divide it into negative 2x squared, and what does that give me? Negative x. Very good. So negative x times 2x is negative 2x squared. Negative x times 7 is negative 7x. I go through and change my signs. The first set zeroes out, which is what you expect every time. And then this becomes negative 12x. And I bring down my negative 42. So then 12x divided by that 2x gives me what? 6, positive or negative? Negative. Negative 6. So this gives me negative 12x. And then negative 6 times 7 is negative 42. I change the signs on both, and my remainder is 0. So my answer then is what I have on top up there, x squared minus x minus 6. Okay? Yes, and then if we're, depending on what we're doing with it, you might need to factor that. Maybe not, but we don't have to right now. Okay? We good? Any questions at all? All right, let's look at one where something a little bit different happens. Let's look at number 7. I think I wanted to do. Let me double check. No, actually, let's do, I don't know, 7 or 8. Which one do you want to do? Where did 6? 7 or 8? We'll do 7. It's fine. So I'm going to take x plus 1, and I'm going to divide it into 3x cubed plus 7x squared plus 2x plus 3. Why don't you try this one on your own? Let's see if you can see how far you can get. If you get somewhere that you get stuck, that's fine. I'm going to work through it with you too. And if you're not even sure where to start, let me know and I'll help you get started. Are you stuck? Okay. I'm going to take 3x cubed and divide it by x. What do you get? So you put 3x squared right here above your x squared. And then take that and multiply it by both of those. Okay. See if you can. Good. Okay. I'll come look at your options in just a second. And if you have 2 different options, don't erase them because I want to see what you have. Well, actually, I'll just pause right here. What are your options? Okay. No, and I'll explain to you why in just a minute. Because you're not actually, these aren't stuck together. You do a plus right there.
No, I know.
Oh, I see what you're saying. Yeah.
What went in between.
Okay, yeah, but you knew what to do. Okay, that's okay. That's good. Okay, yeah, good. So then, no, we don't do anything else there. That's good. Okay. All right, is everybody with me up to this point? I haven't finished that yet. Okay, without looking at it, I'm not 100% sure. Let me see. I think that's right. Here, let me finish this up. All right, so then x goes into here. This is minus 2. Okay, so I get negative 2x minus 2. And then I change the signs, right? And I get, this zeroes out, and then I get 5 here. Okay? Any questions about how to get to this point? Okay, so then my answer. I have a non-zero remainder because I had 0 remainders on the other ones. I have this 3x squared plus 4x minus 2. Now, here's the important part. Whatever your remainder is, you always add it. So this is plus, always add it, and then plus, actually, I'm going to mine's all running together. So I'm going to rewrite the exact same thing. There was nothing wrong with it. It's just running together. Okay, so I have 3x squared plus 4x minus 2, then plus, my remainder is 5, but it's not just plus 5, obviously. It's 5 over what? X plus 1. So it's plus 5 over x plus 1. Okay, does that make sense? We good? Any questions at all? And these remainders are going to mean things to us moving forward. That's why we're practicing on this, because we're going to do different things when we get remainders. They'll give us a few different things depending on what we're applying it to. So they will be important to us. But obviously this one doesn't divide evenly. Okay, are we good? Any questions? All right, we're going to do number 9. Does number 9 look a little scary to you? It shouldn't. I know we're dividing by a trinomial, but I want to show you just because things look more crazy does not mean that they're more difficult. What I'm dividing into is x to the 4th minus 5x cubed plus x squared plus 20x minus 10. What is on the outside is x squared minus x minus 5. Okay? The fact that this power is higher and we have a trinomial changes nothing in what you're doing. Okay? It's the exact same process. So if you could do the other ones, you can do this one. So I take x squared. When I take x to the 4th divided by x squared, what does that give me? X squared. So then I make sure I put it above my x squared term. Lining this stuff up is important. Then x squared times x squared is x to the 4th. Then x squared times a negative x is negative x cubed. Be very careful with your signs. And then x squared times negative 5 is negative 5x squared. And then make sure you do not miss your step where you change the signs on each one. Okay, we all good on that? All right, and then I combine them. And so when I do that, this first term zeroes out. This gives me what next? Negative 4x cubed plus 6x squared. I bring down the 20x. Then negative 4x cubed, I divide that by x squared, and I get negative what? 4x. Stop me if you don't know where something's coming from. Please be brave enough to speak up. Then I multiply these, I get negative 4x cubed. Then negative 4x times negative x is positive 4x squared. Then negative 4x times negative 5 is a positive 20x. So then I change the signs. And when I do that, this zeroes out. This gives me 2x squared. This zeroes out, so I have plus 0x. And then I bring down my negative 10. You need to put the 0x there. It's going to be very important that we have our placeholders. So yes, you need that because things are going to have to line up here. So then I've got x squared divided into 2x squared is going to give me a positive 2, right? So that gives me 2x squared minus 2x minus 10. If I hadn't put that 0x there, I wouldn't have anything to line up with that. Does that make sense? And when your stuff isn't lined up, bad things happen. You get confused and start making stuff up. So then I change the signs on each thing, okay? And these zero out, right? Does this zero out? No, I get 2x. And does this zero out? Yes, so my remainder is just 2x then. Okay. So when the first term that zeroes out, you don't have to put 0x squared, but if there's anything in the middle or on the end, and it's not the very last step, you need those zeros in there. So then my answer in the end is x squared minus 4x plus 2 plus, and then my remainder is 2x over x squared minus 5, oh, not minus 5, minus x minus 5. Any questions at this point? We all good? All right. So then we're going to do one of these two. I think I want to do number, let's see, I'm going to do number 10. Okay, so it says when a power is missing in the dividend, use a 0 to fill in the missing term. It is very important that you don't miss your placeholders, okay? So when you look at these right here, do you see how I have x to the 4th, but there's no x cubed term? Okay, so I can still do this. It doesn't make it more difficult, but when I write this down, so I'm going to have this x minus 8 is going to divide into x to the 4th, and then I have to have an x cubed term. I have to. So what's the coefficient? 0. So plus 0x cubed, then I have minus 64x squared plus 9x minus 80. So you're missing terms, you're missing powers, you have to make sure you have those placeholders. If not, it throws everything off and then your answer is just wrong. And at some point, you're probably making stuff up because it doesn't work anyway. All right, so then I treat it the exact same way I did all the rest, right? X divides into x to the 4th, and what do I get? X cubed. And see, if I didn't put that placeholder in there, I would have no place to write that because I have to write it above the x cubed term. So then x cubed times x is x to the 4th. Then minus 8x cubed. Then I go through and change the signs. So this zeroes out. This was 0x cubed, but I'm adding 8x cubed, so I get 8x cubed. Then minus 64x squared. So then x divides into 8x cubed, and what do I get? 8x squared. Good. 8x squared. So then this gives me 8x cubed minus 64x squared. I change the signs on each thing. So this first term zeroes out, which is what I expect. This term zeroes out, but I need to write 0x squared because I still have to have my placeholder, and then I get plus 9x. Now, how many times does x go into 0x squared? 0 times. So this is a plus 0x term right there. So then 0x times all that is just 0, obviously. So then this gives me 9x, and I bring down my negative 80. So then how many times does x go into 9x? 9 times. So this is plus 9. So this gives me 9x minus 72. I change the signs on each term. And these zero out, and negative 80 and a positive 72 is negative 8. Okay. So once I get here, if I have this 0x term, I write it when I do this, but do you see how I have a spot, every little spot's taken care of? That's how you know you didn't leave off a 0 something else or do something else weird. So when I go to write my answer, which is going to be x cubed plus 8x squared, do I actually write the 0x? No, because you would never write an actual thing that you're doing, but you do it when you're dividing because they're just placeholders is all they are. Plus 9, and then remember you add your remainders. Always add your remainders. So that's plus, then your remainder is negative 8 over what? X minus 8. And it's important that you always add and leave the sign on here because if your remainder was like 3x or negative 3x plus 2, you couldn't just drop the sign down here to make it minus, right? It has to do with distribution and stuff. So the safest thing for you to do is always think you're adding your remainders and then you just leave the signs stuck to whatever they are. And then you're done. Okay, are we good? Any questions? All right, I'm going to give you 4 questions on your homework. There's 8. I'm going to have you do just 4 of them. Just 4 of them, that's all. It's not trick. I want you to do the odd numbers, okay? All you have to do is the odds. Oh, I may not have enough copies. I'm going to have to print some more out. Just 4.